For the next 35, 40-ish minutes, we're going to talk about conversational AI. Hopefully, we're going to demystify it for those of you who are new to it. And for those who already know something about it, then hopefully you're going to learn something new. With that, let's get going. I am Priyanka Vergadia. I'm a developer advocate at Google. I like to call myself as Happy Path Engineer. I built demos and troubleshoot things based on happy paths so that we can help developers and developer communities to learn to use different tools, open source and the tools built by Google. I can be found on the internet as P. Vergadia in almost every social channels possible. And all the code that you will see today, all the demos that I show you is in some way, shape, or form available in either one of the three places that I've mentioned here, or mostly always on Twitter. So you can find everything. And if you need to ask me questions even after the talk, reach out to me directly on Twitter. With that, let's get started. Conversational AI. Conversational AI has been around for quite some time, and I think we all have used it in some way, shape, or form. Since 1950s, it has been around. The first conversational experience was able to identify 16 words, 1-6. And then we moved on to a research and study done by Carnegie Mellon that was able to identify about 1,000 words. Since then, the story has continued, and we've used conversational experiences in a lot of different places, in business and customer support in most cases. And the one that we all can relate to is IVRs, or interactive voice response solutions. For those of you who do not know what IVR is, it's those phone systems when you call in and a software answers and you keep pressing 9 or zeros to get to an agent. That's what that is. And we've all experienced this before through those phone experiences. And why? Why is that? If you think about why we get frustrated with phone experiences that have traditionally been part of our lives, is because it's based on rigid flowcharts. If I said this, the machine has to do this. If I said that, do that. Let's take an example. Say this phone system helps me get coffee. And I make a call, and then this software system answers, and it's like, would you like some coffee? And I say, sure. It's like, what was that again? And I say, get me some coffee. Can you say that again? Do you see what's happening here? It is only programmed to understand yes or a no. When I said sure, it had no idea what to do. When I said get me some coffee, it had no idea what to do because it's looking for a yes or a no. So these experiences, this was a very simple example, but you can understand this and apply it to all the businesses and airlines and banks that you've called in and gotten frustrated and didn't get to the right place or didn't get the right thing done. It is because it's looking for very specific things. And today we are going to demystify what all those things are. This is a very good compiled list from chatbot.fail, which tells you why conversational experiences actually fail. And we talked about one, which is rigid flowcharts. There are a lot of others, which is the use cases that you're applying conversation to is not really a valid use case. You should probably not apply conversational experience to that use case. Or you don't tell the user that they're talking to a bot. You just fake and try to do everything without telling them that this is a machine, so the expectations are set. Or you try to do too many things in the bot, which is also troublesome. And we're going to talk more and more about some of these and touch in some way, shape, or form in our presentation so I'm not going to go into details, but this is a really good compiled list, so I wanted to put it in the presentation so if you're looking at it later. In spite of all of the problems, conversational is still becoming the new user interface. And there's a reason for that. The reason is the large number of devices that we are dealing with today. Starting from when we wake up with a smart alarm to when we sit in our cars and try to navigate without hands-free in the car, take me to the office or take me back home, or to the end of the day, trying to switch on lights and fans automatically without standing up or without using the apps. As we as we go more and more into the IoT era, these devices, we are going to require to, we're going to be unable to use our hands and eyes to interact with every single device that we deal with. We would have to use voice, and that's the way we're going to work with all these newly created devices. And for those reasons, conversation AI is becoming more and more mainstream. And here's another example or a proof point of why conversational AI is becoming more important. 80% of the customer interactions can actually be solved by a well-designed bot. And that's a very important fact because, and we as humans, we are very busy in our everyday life from 9 to 5. We don't have time we are so busy in work that we don't have time to return those shoes that we purchased online. Because if we call in, we're going to have to miss some meetings, or something has to disrupt during the 9 to 5 period. And we would like to return those shoes after we get back home. But then the customer support team for that e-commerce site may or may not be available after 9 to 5. So we do actually want to self-serve ourselves. We would like to be self-served. We don't realize that. So the study shows that 60% of customers want easier and self-serve customer support. So there's definitely a need for it. There's definitely a demand for it. And that's why a lot of companies are investing in it. And we're going to see how to actually build some. But these are some proof points that if you're not already thinking about conversational experiences, then now is the time to actually start thinking from the at least proof of concept perspective. Now, use cases of conversational AI. We talked about customer support use cases. Those are the first ones that come to mind. The e-commerce use case where I mentioned returning something or purchasing something. A lot of retail companies try to do personal shopping experiences. We're helping users what they may want to purchase or buy, and then just general customer support for any type of product. Then the second is controlling the IoT devices, home entertainment systems, switching lights on and off, smart coffee makers, auto to navigate me somewhere or play this music, things like that, switch on my washing machine, dryer, all sorts of things like that. And then the last one, which is very important, and companies are starting to think about this now, which is connecting businesses with employees, increasing the productivity of the employees. So think about onboarding process. How can you make that onboarding process easier using all your knowledge bases in different places? As you can imagine, we have tons of wikis in all the companies. No company has one knowledge base. There are at least 4, 5, 10 knowledge bases in different places that don't talk to each other. Think about combining them together and then interfacing it with a chatbot that can, a conversational experience, either voice or text, that can help onboarding or in help desk situations. I would like to know how many vacations I have left in the year. And I shouldn't have to read through a bunch of documentation from different places in order to find that out. It should be able to authenticate me and then find out if I'm a part-time person or a full-time or whatever my situation may be. It should just tell me, you've got 5 vacation days left in the year, and that's all. You improved the productivity of the person. You made them more efficient instead of them looking for information. Similarly, for organizational knowledge, product knowledge, helping sales and support teams get to the right information quick and fast. Again, combining those knowledge-based systems is a good one. So companies are starting to think about that last use case now. The first two are pretty obvious and very clear, as I gave those examples earlier. Now, we've already come way too far, but there's a reason why I have this slide not as the first, but a little bit later. I think by now you all have probably realized that conversational experience is something that's built off of, that's built more natural, more human-like. So it's built with anything that's built with technology, that's natural language understanding for interacting with users instead of those rigid flowcharts or those programmed interfaces like the IVRs where if user says this, do that. You're basically trying to understand what the user's saying through most natural, and providing them the most natural and rich experience possible. And we'll see how that works. There are lots of different names. It doesn't really matter. When it came out in 1950s, we didn't call it conversational AI. It's a newer term. But in some way, shape, or form, anything that's related to voice bots, chatbots, or all those names that you hear, it's all talking about the same thing, which is natural language understanding. Technology behind conversational AI. So the main and the most important technology, we just talked about it, is natural language understanding. It is that piece of the puzzle that helps you translate a computer to understand the language that we speak, the human language, into binaries, zeros and ones, and then translate that zeros and ones back into our language. That's natural language understanding. I'm oversimplifying it, but that's pretty much what it means in a very simplistic term. Before we move further, I tend to, I think this is not very clear to everybody, so I always like to show this graph just to explain where things fit. Natural language processing is a superset, which is pretty much how you syntactically understand language, how computers syntactically understand languages, parts of speech, grammar, and things like that. And then natural language understanding is a subset which helps us understand more intelligent things like semantics, like spelling corrections, accents, paraphrasing, making something, coming up with a brief or a summary of something big. Those are things that humans can do very easily. Understanding context. That is what natural language understanding lets us do or simplify. And then you're going to come across terms like automatic speech recognition, which is understanding speech as somebody's saying it, and then text-to-speech, very self-explanatory in speech-to-text. Just laying them out all here just because these are all the terms that you come across. And then the best part about natural language understanding and natural language processing is it applies to both voice as well as text. So when you're building experiences, you're not just building it for somebody who is going to chat or text, you're also building it for voice or vice versa. So it applies to both. So if you're building one model, then it applies to both voice and text, which is pretty amazing. To wrap this introductory section up, a lot of people ask me, where does natural language processing understanding fit into the whole, like, is it AI? Is it ML? Is it deep learning? So for that reason, I have this. It's actually a very complicated answer. It kind of falls into all of those three. Part of it is AI, part of it is ML, and part of it is deep learning. So you need all of that in order to apply natural language understanding processing and ASR. Now we get into the main portion, which is what does it take to actually build a good conversational experience? It's actually, as most of you might have seen, a lot of people are building conversational experiences. It's actually very simple to build, but it's very hard to build a good or a great conversational experience. Most of us have dealt with chatbots and conversational experiences that don't go anywhere, that don't deal with the right problems, or just end up leading into frustrations. So we'll talk a little bit about what those factors are that go into building a good conversational experience, and then we'll see what helps us actually, what are the tools that can help you build a good conversational experience. So the first is the intent. When you are building an experience, you need to understand what the user is saying, which is an intent. Whatever is the user going to ask for, or the question that the user intends to ask your application is an intent. So take an example. If I am asking for, if I'm building a conversational experience to get coffee, I'm going to say, and just me, depending on the time of the day, what my mood is, where I am, I can ask for coffee in multiple different ways. And it could be like, can I get some coffee, which is very simple. Can I get some coffee? Oh my gosh, can I get some coffee? Coffee would be great right now. Coffee, right? These are different, like, depending on what I'm feeling, where I am, I have different ways of asking for coffee. These not necessarily grammatically correct also. They could be very different. It could have different modulations and voice and all of that. And then if we go around the room, I came up with 5 or 6. If you go around the room, I'm pretty sure we'll come up with about 1,000 ways in which people can ask for coffee. And that leads into, you need to first grab different ways in which people will ask a specific question to your conversational experience, and then train the machine learning model to understand that 1,001 user that's going to come in to ask for coffee. So from the intent perspective, make sure you're able to identify what the users are going to ask, and then train the machine learning model. You need to understand natural language, so you'll train the model based on the natural language. There might be people saying grammatically wrong things. You need to understand through, in your NLP models, you'll have to make sure you're incorporating for that. There'll be spelling mistakes as well. You'll have to incorporate for those as well. So that just adds to the complexity. So I'll leave it at that complexity, and we'll come back, pick this up again. So the second piece is entities. When somebody is asking a question to the bot, they are going to give you some piece of information that you will take action on. We'll take another example here. I would like to set an appointment for 4 p.m. tomorrow. Set appointment is definitely the intent here. They are reaching out to you to set an appointment. 4 p.m. and tomorrow are 2 pieces of information that your bot needs in order to take an action, which is to set an appointment. So you need to grab those 2 pieces of information, which you can call parameters, variables, anything you like. You'll hear a common term called entities. Entities is those variables that you're going to grab. Now, complexities with those entities, dates, times, currencies, locations, addresses, numbers, these are very common. You'll have to think about even creating models to build those common entities on top of whatever those custom entities are for your business. If you're a pizza shop, you need toppings entities. If you are this appointment scheduler, you need the entities for scheduling appointments. Why does somebody want to come in? I'll show you with an example there. But you need to think about those different, this would also require machine learning for all your entities, custom as well as the very common ones like dates and times. We'll leave it at the complexity and come back to it again. The context is the main and the most important piece of a conversation. You and I can communicate with each other because we have a basic understanding as humans that whatever I said 2 seconds ago is retained. Understood is not the point here, is retained is the point. That is context, right? I can assume that what I said a few seconds ago, and I can build that conversation on top of that assumption. That is the beauty of human conversations. We don't have to learn these things, we just know how to do it. For a machine, you do that or you achieve that through context. And context, there's an example up there, but another example could be, what is the weather in San Francisco tomorrow? And the bot responds back with something, partly cloudy, whatever, right? And then I say, oh, how about Amsterdam? It needs to retain the context that I'm still talking about tomorrow. Same way in this example, I want to book a flight from LA to Hawaii for less than $300, and then it gives me some options, and then I respond back saying, oh, how about to Copenhagen? It needs to retain that I'm still talking about Hawaii to Copenhagen, and I'm still talking about less than $300. Those 2 pieces of information become context, and you need to save that. So the tools that you use or whatever you build has to have the ability to retain context. Otherwise, it's going to be something as plain as those frustrating experiences because you're going to ask for this information again and again, and the user is going to feel really bad and frustrated because he already said it. Oh, and it's not going to feel natural because when humans talk, that's how we talk, right? Because we assume that I told you Hawaii, why are you asking me again? Right? So that is what context is, and we're going to come back to it again. So again, we talked about 3 complexities. There are a lot more. Now think about, as a brand, you are never going to want to produce a conversational experience just for one thing, or just for web, or just for phone. You want the experience to be same across all your channels. If the user comes in through Twitter, same experience. If they come in through the car interface, a smart speaker, everything should jive with each other, and they should all be the similar experience. So you need to build all those integrations for all these different channels. We talked about intents. We talked about machine learning to get to those intents and the natural language processing, and the list keeps growing. If you think about growing or expanding to other countries, you need to think about languages that you would support, and then the models now have to be created again for the new languages. So the complexity starts to grow as you start to grow. The first one is always, it seems that it's easy to get the first one out, but as you think about all of these other things, it starts to become complicated. And then the most important piece, which is you can have the best machine learning and the best natural language processing models in the front end, but if they don't connect properly, if your experience doesn't connect properly to the fulfillment piece, how would the appointment be set up? Like, I have the dates and the times, but if I don't have the proper APIs or connections to those APIs to make that appointment, then all of the work that you've done in making the whole thing natural turns out to be useless. So all of those pieces have to be thought about before you start building the conversational experience. Tools, which is the most important part of this talk. What are the different tools for conversational AI? Now, there's a lot of open source libraries. These are all the open source libraries that are available. Natural Language Toolkit from Python is pretty popular. GenSim helps, it's again written in Python for topic modeling. And Text Blob is written on top of Natural Language Toolkit. It utilizes Natural Language Toolkit. And what it helps you do is, if you are very new, Text Blob is probably a good place to start to learn how you can how you can create paraphrasing and spell corrections and those types of things. Text Blob is really good for that. Spacify is written in Python, and then Core NLP was written by Stanford, and it's written in Java, but it has extensions for all the other languages, mainly for Python. So if you are doing this thing on your own, then starting with some of these libraries could be your best bet or options. But I have some more options that may seem appealing. Again, this option right here on the slide is more for people who are interested in diving deeper, who know a little bit of machine learning, who want to learn more of machine learning and natural language processing. For those who are a little bit in the phase where haven't done machine learning before, don't know if we need it, we can just try something with a pre-built model. Then for that situation, I recommend looking at Natural Language Processing API, which is a Google tool. What we've done there is we've created a pre-built machine learning model for different types of natural languages. I'll show you a demo here just to see what this does, and then we'll move further after. So let's see. This is a very simple example, and it's on the website, so you can even try it. But what it really does is it has been trained on tons and tons of data, which is very generic. And then what it does is it parses out entities. So in this case, it parsed out the location, the person, address, numbers, price. This is deliberately an example to show different entities that it can parse. And then the sentiments, as to whether it's neutral or negative or positive, and then it gives you the syntax for parsed labels, parts of speech, the grammars, and then it also tells you what category this text kind of belongs to. You could also try, let's try, I am really frustrated with your service, with your customer service, right? This is just some random example to show that, okay, we're talking about customer service as an entity. The sentiment, really bad because I'm frustrated. So it could pick that up and then does the syntax and categories. Again, this is only to point out that there are, how do I go back? Okay. So this was only to point out that you could, if you don't want to deal with machine learning or natural language processing, there is an API that you can utilize. I think the initial usage is really free. So you can try it out if it works for your business use case. And then if you're just doing normal customer support, customer service type things, it should definitely work. And then you apply text-to-speech and speech-to-text models that are also pre-built. So you're not building any of this, you're utilizing pre-built models in your specific use case. So as long as you have a developer that, or you are a developer, you can combine those three together and then build a conversational experience without having to learn machine learning or natural language processing. There could be situations where that natural language API out of the box is not good enough for your use case. For example, it doesn't, you have some specific product names or things that you want to identify that it will automatically not do for you because it's trained on very generic data. You can use that and apply your data on top of it and create custom machine learning model, in which case also it's a graphical user interface where you just drag and drop the data that you have and it'll train the model and create a custom API. So again, second example, or I guess the third example of not having to learn too much of machine learning and natural language processing and still being able to deploy a conversational experience. Third, and the last option that I think is a good one for somebody who is pretty new to the whole conversational experience space, does not have much of a development experience, want to bring something to life really quickly and fast. There's a tool that we have called Dialogflow, which basically combines the previous slide that I showed you. It is a pre-built experience of a combination of natural language API, text-to-speech, speech-to-text, bundled into one. It's called Dialogflow, and it takes away, all you're going to do is when in that coffee example, you're going to feed the 100 or some examples in the text as training phrases, and it trains the model on its own. You just click on train, and we'll go see that in a demo. But that takes away that complexity from the developer's perspective, and you don't need to really know a lot of machine learning. As long as you understand the terms and the phrases, you'll be able to survive and build a good conversational experience. I've talked about all of this. It comes with 20 languages and 14. Let's look at the demo, and then we'll come back to, I'm pretty sure there'll be questions on this, so we'll come back to it. Okay, so what I've built here is very random, and I say random because it does two very different things. So I'm greeting the user, and I'm saying you can set appointments, and you can explore landmarks. Again, two random things. Setting up appointments, I'm going to, let's say, I would like to set an appointment, and it'll say, when would you like to come in? And let's say 5 p.m. And then what date? Let's say tomorrow for license. Right? I basically provided 3 pieces of information. I want to come in for license at 5 p.m. tomorrow. And it went and created an appointment for me. And you can see that here. So I don't know what happened between my travel from San Francisco to here. It has some time zone differences. So when I say 5, it sets up appointment at 4. When I say 2, it sets up at 1. So I have to fix that. But you get the idea. It's going to the calendar, and it's setting up an appointment. And I'll show you where it's doing that. That was one, and we'll see how all of this actually came to life. But before we do that, there's one more use case, which is I can upload an image, and then it'll tell me what's in that image. So yesterday, I came in the afternoon, and I went to, I'm pretty sure I'm going to say this wrong, Nahawen? And we'll see if it comes back telling me that it is that in the image. And it does. So it's very simple. what we're doing here, it's basically going to a custom machine learning model. It's it's looking for what's in that image, and then it's telling me what's in that image. But in a real use case, what you're probably going to do is imagine receipts and returns. Somebody, you want to do automated returns. You want somebody to upload a receipt. You want an OCR model to look at the receipt and be able to say, this was purchased on this date, still valid to be refunded, and then you automatically process the refund and send it back. Imagine another use case where there could be problem with a product, and you ask the customer to take a picture and send it to you. And then they upload the image, send the picture, and then a custom machine learning model kicks in, and it tells the user that yes, it is in fact default. It's a fault in the system, and then we will send you a replacement or something. So imagine use cases like that. Those are much more business-focused use cases. I just wanted to show the art of the possible. That's why I'm just using random stuff like, here's the Eiffel Tower in this image, or something like that. But you could use it with a custom machine learning model. So that's what is happening there. Let's see how the architecture looks like, and then we'll jump into the Dialogflow interface which I used to build it. So in any, and you can do this with any technology and deploy it anywhere. I'm obviously doing it on Google Cloud. What I've used as the front end is Django framework. Django framework allowed me to build that front end where I'm having the user type in, hi, hello, whatever it is that they want to do, and then upload the image. That's all done in Django. I have deployed that application on App Engine. App Engine is really platform as a service. I didn't want to deal with how many servers and how many instances of this server, so I just did it on App Engine, where it scales on its own if there are lots of requests, and it scales back down if there are none. Cost effective and also easier from the developer perspective, because I don't have to think about much of the infrastructure aspects. The image that we uploaded goes into cloud storage, because I don't want the app or the front end to be heavy on image. So we're saving that in cloud storage. You can save it anywhere you like as storage. And then the request, when we set an appointment, that request triggers Dialogflow's API. So Dialogflow detect intent API gets triggered, and intent is identified as setting appointment. And then once that is identified, it goes and calls the calendar API to set that appointment. It also, once you've uploaded the image, it goes and calls the vision API to understand what's in that image, grabs the file from cloud storage. There's an arrow missing there. Grabs the file from cloud storage, and then identify what's in that image, sends it back to the App Engine, sends it back to the user, which is where we see this is what is in the image. So that was really quick, because I want to show you the code. Nothing is complete without the code. So let's now see how this was done. So this is my, and I've built this in Dialogflow. Obviously, you can use any of those libraries that I was talking about, or you could use the combination, depending on your comfort level with languages and with machine learning in general. You could use those other options as well. Intents, when I create intents, the default intent comes with the first time when I create it. Okay, it's signed me out. Okay, so, and it's not order pizza, it is this one. So when I first create the bot, it's called an agent. In most cases, it's called an agent. And then it creates a default welcome intent, which is when the user would say, hi, what do you want to do? In our case, what I've done is when they say hi, hello, any sort of greeting, I just give them a very simple response saying, can you all see at the back? Okay. A little bit bigger. Setting up appointment and explore landmarks. This is what you saw when we were trying it. This is not a very interesting option to show, so I'm going to go into schedule appointments, which is the one where we are actually doing a lot of collection of information, right? So I'm setting up. Let's try this. I would like to set an appointment for 5 p.m. tomorrow for license or something, right? And then see what happens. This is magic. It basically parses out the time, the date, and why somebody wants to come in. And this is happening automatically because we've initially set that up as entities. Entities are those variables that we talked about, and the system time and date are general. Every user might be able to use time, date, currencies, and those types of things, so you don't have to build a model for it. Dialogflow has already pre-built models for those things that you might already use. Appointment type, however, is something that is very specific to your application. In this case, this is like a Department of Motor Vehicle example that I'm taking. So in this case, I'm saying that people may want to come in for driver's license or for vehicle registration. And those are the two things that I may hear from the user. There could be another thing which you can add. You could also parse entities through regular expressions. You could also do some fuzzy matching, which is if it is something like this, even if it's a spelling mistake, I'm going to try to match it. So you could play around with some of these things when it comes to entities. If you're a pizza shop, your toppings would be a custom entity, which would go here, and then you would put all your toppings in there. So that is what entities does. The other cool thing that's happening in that schedule appointments is it has those variables. You can mark them as required, so it reduces frustration when time comes when the user is only given one piece of information and you still need two more, or they've given you two pieces of information and you just need one more. So you're not, traditional systems would ask for all of those things again. In this case, you're basically making it smarter and training it in a way that it's asking only for the required things. So if you go back to the example that we were looking at, I deliberately did not give the information about anything. I just want to set an appointment. So it still mapped it to intent, that is setting appointment, but it's still looking for the three pieces of information. So it asked me what date, and then at what time, and then I gave it 5 p.m. When it said what date, I gave it two pieces of information. Instead of just date, I gave it why I also want to come in. And it was still smart enough to take those variables in and apply it. It didn't ask me for why do you want to come in again, right? Because I already gave it. This is making the conversation look more natural, more human-like than traditional systems. And the term for that is called slot filling. You're filling things that are missing, and you're still moving the conversation forward. Now, the last piece here is we need to send all this information that we got to the calendar so that it can set up appointments. So we would write some piece of code. You could create your own webhook. It could live anywhere you like as long as it accepts post requests. HTTP post requests, you can host it anywhere, and you would enable this. In my case, I'm using the inline editor, which is a very light and easy serverless function, and all it does is make calls to the calendar API. So in this case, this is how it works. So we have the intent, which is called schedule appointment. When schedule appointment intent is triggered, I want to trigger the function make appointment, and then make appointment is where I am grabbing the parameters from the agent. So Dialogflow gets all the parameters in agent variable, and then you can do agent.parameters dot whatever is the variable name or entity name, and you can grab all of those variables that were used in the entire course of the conversation. So in this case, I'm grabbing agent.parameter.appointment type, and then agent.parameter.date and .time, and this is giving me the date, time, and the appointment type, which I'm passing to another function, which is creating an event in the calendar. And then in that event, I'm basically just checking whether the appointment is set or not, and if there's a conflict, and then if there is none, then I set the appointment. And then I respond back to the user, which is, again, going back to the same place, and I say, tell the user that the appointment is set up, and then, of course, there's service accounts and authentication happening with the calendar API and my account in Dialogflow, but all of that is simple enough to set up. The one where we uploaded the image is where I'm saying the intent is, let me go back to my apply. When you upload the file and when that intent is triggered, you're calling apply machine learning, apply ML function, and then that function is really very simple. All it's doing is grabbing the file from file storage. It's calling the Vision API. Once I have the result, I'm just saying this picture is of whatever label was found. Not even parsing much in there. And then in that API, I'm calling landmark detection. You could call OCR detection. You could call other things that you're doing through the machine learning API. You could even call a custom machine learning API from here. Whatever it is that your use case is, you would just call that on the client, and then use that image that was stored in cloud storage, grab it from there, pass it to the machine learning API, and then see what's in that image, respond back with the result, and then tell the user what was in that image. Seems pretty, like I'm also sending this data of the appointment into BigQuery where you can do further processing with, oh, how many appointments am I getting for this versus that, and you can do more with it. The idea being I wanted to show that you can interface it with any backend system that you have, connected to Salesforce, grab tickets, connected to whatever it is that you have at the back end that can help serve the use case that you want to serve. Integrations is the most important piece. I have it enabled for web, so and it is all one-click integrations. All you do is enable this integration, and then when I click on it, everything that I just showed you can be done through the iframed piece of bot. So you can take this and iframe it into your application. Most people don't do that because they want it to be on brand and look as if it's their own build. For those reasons, I've created that custom one. You can have it on Facebook Messenger, enable it for Google Assistant. So you're building it once, but that experiences can be enabled across all of these different channels. Twilio, Skype, all the others. A little bit different for Amazon Alexa, but you have to download and then you have to upload. Which is a little bit different than just enabling a toggle, but still possible. And then this is a cool one I like to show. Although it's a beta feature, the whole experience is available if you just provide, it's available as an IVR basically. So you provide a phone number, and the whole experience that you're doing with chat and other voice applications, you're going to be able to provide through the phone. So it basically starts to act as an IVR. Only available in US at this point, but a cool one to show, that's why. With that, let's hop back into our slide deck here. I showed the phone. I didn't show the knowledge connector, but that is where you can upload a frequently asked questions in HTML or text format. So you have an FAQ on your website. You want to turn it into a bot. It's very easy to do. You just give the HTML link, and it will generate questions and answers, so intents and responses. And you can play around with that as a viable bot application. Looks for spellings and corrections, looks for sentiments, looks for, like I said earlier, it has text-to-speech built in, so you're not doing a lot of these things, although you can if you choose to, like I showed earlier, but if you don't want to, it's all in there for you, and you just use the tool as if you're building a use case, a business case. Before I end, I always like to show this because we are always in a hurry to just start. As developers, we just want to start building something. I think this is a really good indicator of how to actually build good experiences. They start from the journey. They start from identification of what is that use case that we should be building for. You end up into situations where you've built a use case that was not very good for voice. So instead of falling in those traps, if you jump in quick, instead of falling in those traps, you think about what those user journeys are that you may want to implement in voice or text. and then and then once you've identified those 2 or 3 user journeys, then build a business plan. And I don't mean like a traditional business plan here. I just mean build a plan as to where the data is going to come from, what the users are going to say, what are my backends going to be? Do I have APIs for that? Do I have everything I need in order to make these 3 use cases work? And then design a persona. Make sure that your bot is perceived as somebody. It has its own identity. It feels like your brand. It feels like if you are a nerdy type company, it feels like it's a little bit nerdy or funny or however it is that your brand is, give it some persona. And then write some professional scripts, meaning write scripts to say, if the user says this, these are the things that should happen, or they say this, these are the things that should potentially happen. How would I handle an error? What would an error be in this case? Because in conversations, it's very hard to identify errors because there are no errors in a conversation. What would you call that error situation, and then how would you come back on track from there? So those are the things that will happen in the 4th phase. And then connect with your enterprise systems. Think about all those systems that you're going to connect with, if it is ticketing, Salesforce, or Zendesk, or whatever it is that is, or databases. Think about those. And then you start to collect feedback, and then you start to implement. So you don't just go and build something. Start to think about all those use cases that are going to make sense to build, and then jump into building. Do not forget that last piece, which is very important. Connect to the human agent. If there are going to be situations when people are not going to be happy, make sure that you have a plan for that. If they are not going to be happy, then when are those situations going to occur? What is your threshold for those situations? And make those connections to the human agent. And most people, they think about sentiment. So we have sentiment score in there. You could get your own sentiment score if you're doing your own machine learning and natural language processing. Make sure you track the sentiments. If the sentiment score goes below whatever, minus 0.5, right? I need to trigger a real agent. And then the call goes to the real agent, or the chat goes to the real agent. So think about those situations, and then end up starting to build something. With that, that's me again. You can reach me with questions. I think we're going to open up for questions here. I also have most of the code for all the things that you just saw on GitHub, and some Medium blogs, and also on Twitter. There's also, if you want to follow along me doing this, or when I was building this, the Deconstructing Chatbot series is a good one to do if you need comfort while having somebody do it. There's also code labs if you want to do things independently and get to the code that we just saw today. So feel free to check those resources out, and you can always reach me later as well. And thank you so much.